So our factoring unit is going to start with the greatest common factor. And the greatest common factor is the first thing we always look for when we do factor. So when we have monomial terms, single terms, we are going to start with the coefficient. So the coefficient is always the number in front, and we're going to ask ourselves, what is the largest number that goes into both of them? Then we are going to look at the exponents on same variables. So for instance, if you have an x and a squared and an x to the 5, like I do in example A, you are going to look at the exponents, and the GCF will be the smaller exponent on those like variables. So we're going to just identify the smaller exponent, and that becomes the GCF. So let me explain the first 4 examples that are worked out for you, and then I can obviously let you guys try. So for A, when we look at the coefficients 8 and 6, we think about what is the largest number that is evenly divisible into 8 and 6, and that would be 2. If you think about it, you guys learned how to reduce fractions, and that's the same idea. So 2 would be the largest number that is evenly divisible into both 8 and 6. And then when I look at the exponent part on the same variables, I go with the smaller exponent. So the greatest common factor is 2x squared. Now, if I want to factor out the GCF, I am going to divide each term by the GCF. And I'm going to get into that in just a few moments. As a matter of fact, I have my notes ready to go so that I can show you guys in a few moments. So I'm not going to show it just yet. Sorry, I have emails popping up. For the next one, the GCF of 9 and 3. So we're going to start with the coefficients. Well, the largest number that divides into both 9 and 3 would be 3. So 3 is part of the GCF, or is the GCF, I should say, for the numerical portion. And then when you look at y to the 5 and y to the 12, we go with the smaller exponent. And so 3y to the 5th would be the greatest common factor. It's going to make a little more sense why we go with the smaller exponent when I get to the bottom examples there. For letter C, we have 16 and 24. So the largest value that goes into 16 and 24 is 8. 8 goes into 16 twice, 8 goes into 24 3 times. And now we have multiple variables. So guys, it is important that you go with one variable at a time. We have 8 to the 5 and 8 to the 1. So again, to reiterate, we always go with the lower exponent. So 8 to the 1 would be part of the GCF. And then we have b to the 2 and b to the 4. So b to the 2 is smaller than b to the 4. And so it's ab to the second power. And finally, we have d. So 20 and 15, the largest value that goes into those is 5. I have an a squared in the first term, but no a in the second term. So a is not part of our GCF. And then I have b to the 3 and b to the 6. So b to the 3 is the smaller exponent. So before I take questions, what I'm going to do next is I'm going to model 2 things now, identifying the GCF and then factoring it out. And I'm going to do that with the examples on the bottom. And then you guys are going to have an opportunity to try this without me. So let me start with A. There are 2 terms separated by a plus sign. So for A, and I'm just going to work them out on the side so I have room. The greatest common factor for 3 and 15 is 3. The first term has an x, the second one doesn't, so 3 is the greatest common factor. When you factor out the GCF of 3, what you are essentially doing is you are dividing each term by the GCF, but you're putting it out in front of the parentheses. So 3x divided by 3 would be x. 15 divided by 3 would be 5. If you are unsure if you did this correctly, what you can then do is you can distribute, and you can see that you would get back 3 times x 5. So that is our first one. And again, I know this is going to be a little bit weird in the beginning, but let me just go through each example to kind of give you the idea, and then hopefully it will make more sense. So for B, you have 16x, excuse me, 16 and 6. We start with the numbers first. So for 16 and 6, the largest number that divides both of those would be 2. Okay, and I'll just identify that GCF. For x to the 3 and x to the second power, we go with the smaller exponent. So x squared would be also part of the GCF. So again, I'm going to be honest with you. You really should try to not do this each time, but in the beginning, if it makes sense, then do this. But what we are essentially doing is we are dividing the GCF out of each term and placing it in front. So 16 divided by 2 is 8. X to the 3 and x squared is x. 6 and 2 would give me 3. And the x squareds cancel. And again, if you wanted to check your work, you could distribute. I'm not going to do that just because of time. So let me do letter C. We have 7 and 12. Now, 7 and 12 do not have anything in common, and that's completely fine. You're not going to always have a GCF be part of your coefficients. But y to the 2 and y to the 4, again, we go with the smaller exponent. So again, we're going to take each term and we're going to divide it by the GCF. Okay, again, this is the greatest common factor. This will, of course, go in front. So we are left with 7y squared plus 12 when all said and done. And again, I'm just going to reiterate that if you do want to check your work, you can use the distributive property. I'm just going to erase this for some more room because I want to really work each one out. So I'm going to put letter D up here. Again, I know this is a lot of me talking right now, and I'm just going to ask you guys to hold your questions for me till after. Okay, I'm be more than happy to help you with them after I go through these. So Indira, I'm just going to lower your hand for now. I will get back to any questions you guys have in a few minutes. For our next question that we have, so we have 24, I'm up to date. So for 24 and 16, the greatest common factor, do me a favor, guys. When you have a question or something you want to comment about, please write it down so that way when I do open up, I can take them. If I keep stopping for questions as much as I want to, and if we were in person, I'd be able to more, it gets to really backlog us on the time. So please just write down whatever your questions are, and then I'll take them as we go. Anyway, 8 for D for 24 and 16. A squared and a to the 5th, we go with the lower exponent. B to the 3 and b to the 5, we go with the lower exponent. So again, here is our original problem. I'm just going to use the space up here because I ran out down there. Okay, so again, we are dividing the GCF out of each term. And you did this in the division last unit, so you guys should be familiar with this. So the GCF comes out in front. We're left with 3b squared plus 2a to the 3rd power. And by now, you guys should a to the 3rd power, and you guys should be relatively familiar with this division and how it works. So as long as you are careful and you divide by subtracting those exponents like we've discussed in the past, there should be no issue. I'm sorry, my face is so close. I'm just looking at my notes. We're up to letter E. And again, of course, you can use the distributive property afterward. For letter E, I have 15M. Oh, somebody write GCF. And I have 9. So between the 15 and the 9, 3 would be the common value. 3, and then we have an M and an M squared. So M, there's an N to the 4th in the first term, but no N. I'm saying N to really show you N in the second term. So we will only have 3M as our GCF. Again, we are dividing out the GCF from each term. So 5, the M's cancel, N to the 4th, and then 3 and M when all is said and done. I'll do F and G on the bottom down here. So F will go right here. Now we have 3 terms. So I have a 20, a 15, and a 25. So for all 3 terms, the common value for the numbers is going to be 5. I have an a to the 4th, an a to the 2, and an a to the 1. So we go with the lower exponent. I have a b to the 4th, a b to the 3, and a b to the 5. So I go with the lower exponent. It's always the lower exponent. Again, I'm going to take my original problem and I'm going to divide each term by the GCF. Again, if you don't want to do this step, it is not necessary in terms of writing it out this way. But I think for those of you that might struggle, this might be a little bit easier. So I'll suggest it as a way to do this. Okay, again, the GCF comes out in front. We're left with 4, a to the 3, and a b. So that's our first term. A 3a in the second term, and a 5b squared in the third term. And again, one more time, you can reiterate that this is your answer by using the distributive property. Finally, G is a special case, and we're going to actually see this in our factoring by grouping. Because the plus it always separates us, we are going to look for something that's common on both sides. And if you notice, x plus 1 is common on both sides of this expression. We're going to factor out in G a GCF of x plus 1. Let me write down that is the GCF. Okay. And when we factor out the GCF in each of our terms, we will be left with whatever's left over. Okay, so let me show you. And again, if G is a little funky, that's okay. So x plus 1 comes out in front. So here we're going to just be left with x in the first term. Let me use a different color to show you. And then in the second term, a plus 4. Okay, so I'm about to open up for questions, not just yet. Let me just quickly reiterate what I had said. And then I'm going to allow you guys to ask questions, whoever has. And as you are ready, you can also start to work on A through F on the next slide. Those will be for you guys to try, and then we'll go over them. So let me just reiterate what just happened. The GCF, let me just move this out of the way. The GCF is the largest number and variable that goes into given terms. So we start with the coefficients. We look for the largest number that divides into all of them. And then when we look at our variables, we go with the lower exponent on those common variables. We are going to divide each term by the GCF. And then, of course, the GCF goes out in front and we rewrite what's left over. So here's what I'm going to do. Indira, I know you were first, and then I'll take anyone else. It is now 8:23. You have 1, 2, 3, 4, 5, 6 problems. So by 8:30, I'd like to start going over these at the latest. So please start to ask your questions or start to work. Indira, you were first?
Yes.
Thank you for waiting, by the way. Go ahead.
On the number C,
Okay.
how did you get the Y?
There's no Y there. That's a G. That's the letter G. Maybe that. There's no Y.
Numbers and number C. I mean, letter C, sorry.
I apologize. I was looking at E. Okay. So for letter C, 7 and 12 are not divisible by anything in common. Agreed?
Yes.
Okay. But the variables, y to the 4 and y to the
Yes.
So because it's the same variable, remember the rule, we go with the lower exponent on common variables. So y to the second would be the lower exponent on y to the fourth and y to the 2. Let me know if that's
okay. I get it now.
And that's the same regardless of the question. Like even in F, the really nasty one, right, where we had multiple terms, if you look at a to the 4, a to the 3, and a to the, or it's a to the 4, a to the 2, and a is the smallest one. You know, a to the first, I should say. When you look at b to the 4, b to the 3, and b to the 5, b to the 3 is the smallest. So just to reiterate, as a general idea, we always go with the lower exponent on those common variables. Okay?
Yes, I get it now.
Okay, awesome. And thank you for waiting. Please, anyone else at this point while people are working, I'm happy to clarify anything. You might also want to test yourself and see if you can do the GCF without the dividing like I did. I will go over it the way I showed you, but you may want to attempt to do that. For anyone that came in a little later, we are on lesson 5. I would say I printed this, I sent you guys an email that this was, there were a couple of typos. So this is the most recent one, which I posted around 3 o'clock today. So if you didn't download that one, then I'll ask you to please do so. Okay, we're going to get started rather soon with the next 3 in about 5 minutes, or the next 6, I should say. But if anyone needs me, I am here to help. Please let me know. I'll stay quiet. Okay, so we'll start in about 4 more minutes. If you are finished early, what I'll encourage you to do is use the distributive property to check your work. Yeah, Maria, go ahead.
Yeah, I just wanted to ask you, for the B, do they both need to have common GCF?
For
Or
let,
do you take like 12A and 11A?
okay, so
Do,
talking about the numbers.
yeah, the numbers.
So that's kind of similar to the question I just went over, which was C. In letter C, you had 7 versus 12.
Uh-huh.
So if there's nothing in common to the coefficients, then there is technically the GCF is 1, but we're not going to write 1.
Uh-huh.
Okay, so it's not always the case that the numbers will have something in common.
Okay.
And by the way, you're going to see that it's a good question you're asking. You're going to see what you're asking me right now come up a lot.
Okay.
Okay, so yeah, it's a good idea to just be on the lookout for that. But a lot of times there is something in common, and a lot of times there aren't. So it really can be, it just is based on that situation you're dealing with.
Okay, got it. Thanks.
You're very welcome. Okay, we'll start in about 2.5 more minutes. If anyone has any remaining questions, you're welcome to ask. Again, this should be somewhat familiar to you guys. It should be clicking. Remember, I'm also recording this, so I will post this for you either later today or in the morning. Sorry, I just wanted to make sure I close that. Okay, so we'll get started soon. You should be wrapping up. I'll maybe add one more for good luck. I always do this because I'm annoying. But why don't you guys try something like R times R? Let's try this. This is a nice one. So anyone that's done, you could try this one. Okay. So F and G and the other G are all kind of similar. And again, I'll remind you of where you're going to see that not too long from now. Okay, so we'll start in about 1 more moment. Sorry about that. Just want to check on something. Okay. Last minute or so, 30 seconds. Okay. All right, let's see how we're doing. So for the first one, letter A, the GCF, or the largest number that goes into 16 and 20, is going to be 4. For x to the 3 and x to the 4, we're going to go with x to the 3. Now, what's nice here is I actually gave room. I should have done that before. So again, the GCF comes out in front. You should have had 4x plus 5 inside of the parentheses. So what you're actually doing is you're undoing the distributive property. The distributive, I can't speak, property would have been to give out the term into each part in the parentheses. So what you're doing right now is you're actually undoing that. Again, let me go over all of them and then I'll open up for questions. 12 and 11 do not have anything in common, but 8 of the 3 and 8 of the 1 have A in common. So the GCF would only be A in this case. So in this case, sorry, somebody in class. Okay, sorry. Somebody's asking me if we didn't have class. We do have class. Okay, so we're going to divide each term by A. we get 12a squared minus 11. And one other thing, I didn't want to say it before to confuse you, is if you guys look inside of the parentheses, there shouldn't be anything else in common to your terms. And that's how you kind of know you're done. For letter C, the greatest common factor, well, you have a 1 in front of this y, so that's not going to really count. So you have 1, -6, and 2. So there's going to be no numerical GCF other than 1. You have y to the 5, y to the 2, and y. So y would be the common factor there. We're left with y to the 4 minus 6y plus 2 as our final factoring for that, or with that GCF. For D, 16 and 10 have 2 in common. X and x to the 4th, we go with the lower x, y to the 3 and y to the 6, we go with the lower y to the 3. Again, we're going to write that we're dividing everything by 2x, y to the 3, that's our common factor. And we're left with 8x cubed minus 5y cubed, as our answer. Okay, so now we're up to a 3-term expression. Again, in a 3-term expression, we are going to look at each term, so all 3. So 21, 7, and 14 have 7 in common. And again, we'll divide by that. S to the 1, S to the 3, and S to the 2, we go with the lower, which is S. T to the, what, who I don't know. Give me one sec. T to the 8, T to the 4, and T to the 2, we're going to go with T to the 2nd power. Okay, so hopefully this is really clicking, and we're going to work extensively with GCF throughout this entire unit, so it's not going to go away. I promise you that. 7st squared comes out in front. We're left with 3 T to the 6 minus, that's going to be S to the 2, T to the 2, and then plus 2s and the t squareds cancel. So honestly, if you're not recognizing by now that squareds cancel, then you should be in good shape there. Again, if they're the same exponent. So either way. For F and G, the common value is that binomial again. So I'm just going to make a little note for that of that to you guys. So this is a binomial GCF. We know that there is a separation of each of these by the minus sign. So the GCF is going to be x plus 5. And again, you're going to see this a lot in lesson number 6 when we do what we call factoring by grouping. When I factor out x plus 5 from the first, I'm left with x. And when I factor out x plus 5 from the second, I'm left with minus 4. And we put that in its own set of parentheses. And finally, G, and then I'll pause for you guys to ask anything. So again, the binomial GCF is going to be 4r minus 3. I'm going to put that out in front. And when I factor that out, I'm left with r minus 7 in its own set of parentheses. And again, I'm just going to put a little star next to F and G so that you guys can really recognize that. And that, again, I don't know if you want to make a note of it in your notes right now, will be an intricate part of factoring by grouping. Okay, so we're about to conclude GCF factoring. Does anyone have any questions for me they would like to ask before we go into our next case? Maria?
Yes, so in F, I mean, in all of them in general, do we need to put, like, when we factor out x plus 5 first, do we need to put it in a parentheses, or we can just look?
Yeah, because it's so for F, G, and the other G that I modeled for you guys, you would want to put that in parentheses because you are factoring out a binomial or a 2-term expression. For all of the other questions, A, B, C, D, and E, you are only factoring out
One.
Yeah, one, right, a monomial. So then parentheses on the monomial would not be necessary. If you put parentheses around it, it's okay, but it really actually isn't appropriate. So you wouldn't be wrong, but we don't normally do so.
Okay.
Okay, Nizar, you're welcome, Nizar.
In C.
In C.
we can't use 2 as it goes into 2 and to 6 because
No.
6 is a negative?
Because the first term has only a 1 in front. So again, remember GCF means that it's going to be common to all of your terms,
Got it.
right? So it has to go into every single term, not just 2 out of the 3.
All right, thank you.
You're welcome. Remember, common means common to all. Okay? Okay, you're welcome, guys. So now we're going to move a little bit off a topic just slightly, and we're going to talk about our special type of factoring, which is known as a difference of 2 squares, or a difference of 2 perfect squares, if you want to add that in. Now, you guys should be familiar with your list of perfect squares. So your perfect squares mean, let me give you a definition, and we're going to do radicals and all of that later this term. I just have some notes over here as well. That's why I'm looking this way. So a perfect square is a number that has 2 equal factors that give us back that number. So let me go through the list and explain why. 1 is a perfect square because 1 times 1 are the same numbers to give me back 1. 4 is a perfect square. 2 and 2 are the same numbers to give me back 4. 9, 3, and 3. 16, 4, and 4. And if you look through the rest of this list, I stopped at 144. We generally don't go past that in this class. If we do, I will let you guys know, and then you could get upset with me if you need to. For exponents, perfect square exponents will be even. Okay, so let me explain why. X squared is a perfect square because x times x give me back x squared. It's the same value. When they are multiplied by each other, they give me back what I started with. X to the 4th is a perfect square because x squared times x squared is the same factor to give me back x to the 4th. And we generally don't go higher than x to the 6th in this class, but x to the 6th is the perfect square because x cubed times x cubed are the same, 2 factor to give me back x to the 6th. I'll come back to all of this in a few. I'm going to now tell you how this all comes into play. So if we have a difference, so difference is going to imply subtraction. So if I have a minus sign in between 2 terms that are perfect squares, they will factor into the same binomial. One will have a plus in between, one will have a minus in between. And no, the order does not matter. So let me repeat what I just said one more time. If I have a minus sign in between 2 terms that are both perfect squares, then I am going to factor these into the same binomial. One will have a plus and one will have a minus in between. Now, I know that might sound like a lot, so let me demonstrate how this works for you with these examples, and then you guys will have an opportunity to try. So I'm going to actually do, how many are here? 2, 4, 6, 8. I'm going to do 4 of them, and then I'm going to let you guys finish the rest of them. So let me start with A. First of all, I see a minus sign in between difference. X squared is a perfect square. Its square root is x. 1 is a perfect square. Its square root is 1. Now, I like to break it down underneath because watch what happens. This will now factor into the same binomial. 1 will be plus, 1 will be minus in between. The squares of each of the terms go in the parentheses. So the square root of x to the 2nd is x. That goes in first. The square root of 1 is 1. That goes in first. And that is my answer. And again, the order of these 2 terms does not matter. I want to do another similar one to the one I just did. So let me do this one for you guys. So let's say I had x squared minus 16. Well, again, I have a minus. So there's my difference, my implied difference. I have a x squared, which it's a perfect square, and I have 16, which is a perfect square. So this will factor into the same binomial. One is plus, one is minus. The order does not matter. I'm going to actually only do one more of these, and then I'm going to let you guys try the rest. So I'm going to actually really throw you guys into this. So let me do letter E. Oh, no, not letter E. I'm sorry. Let me leave these for you guys. I'm going to make up two more, and then you guys will do the rest. So let me make up two more of them. So let's do 25 minus 9x to the second power. So just write that in your notes. I'll give you a moment. So I have a minus in between. By the way, if there's a plus in between, it's not a difference of squares. I always have people ask me that. So let me reiterate. If there's a plus in between, it is not a difference of squares. 25 is a perfect square. 9 is a perfect square. And x is a perfect square. This will factor into the same binomial. And I go in order. One is plus, one is minus in between. Okay, let me model one more for you. I'm going to put your hand down because I did not open up for questions just yet. So guys, I'm not ignoring you. Just please wait on me for the questions. Let's just try one more for good luck. This one's going to be a little trickier, but I think you guys can handle it. 4/9 x squared minus 49. Okay, so why don't you guys write that one down? And again, I'll give you a moment. Okay. So there's a minus in between. So that's the first thing I need. 4/9 is the perfect square. 4 on the top becomes 2. 9 on the bottom becomes 3. X squared is a perfect square. And 49 is a perfect square. So we'll factor into the same binomial. One is plus, one is minus in between. Okay, so there are 7 more problems. Let me see the time, 8:42. So let's say, I don't know, about 8:46, 8:47 maybe, but now I can take questions. So Maria, I can answer yours and anyone else that needed me at this point.
Okay, so in the first example that you gave, 25 minus 9x squared,
Yes.
do they or both of them need to carry square
Both
or?
perfect squares. If one of them, if any part of them are not perfect squares, then it can't be factored.
So so I understand. My question was like, do you need like a square thing, like the sign on top of, let's say 9x minus 25?
Like a square root?
Yeah.
No, you're just mentally saying the square root in your head.
Okay.
Okay, you're
Okay.
not putting the square root symbol. You're just kind of mentally saying square root.
Okay, got it.
Yeah, you're not going to put it, but mentally you're going like square root 49. I see what you're saying. Yeah, you're mentally doing it.
Okay, thank you.
Absolutely. Yeah, you don't want to write that and then start messing that up in your head because that could get a little, that could also like make it look a little confusing in all of my honest opinion.
Okay.
Okay.
Got it.
Yep.
Got it. Thank you.
Absolutely. Anyone else with any questions, please feel free. Okay, so I'll leave you guys to it. I'm just getting my next thing ready. But yes, if you need me, I'm here to help with anything you guys need. Okay, so we'll say a few more moments. We're making really good progress tonight, guys. I'm really happy. I'm going to go over the first half of the exam at the end of class, just in case anyone came in a little later. I'll go over that. I'm just looking at one quick thing. Okay, so it's just around 8:45. So I'll say another 2 minutes or so. And again, if anyone else came in a little later, I also wanted to mention lesson 6 is also part of homework 5. So homework 5 is not due till next Wednesday. It should say that just in case you didn't catch the due date. Okay, so let's see how this went for you guys. So these are all difference of squares. I'm not going to go over minus in between, but you guys have to sort of train yourselves to recognize that. So y squared is a perfect square and 4 is a perfect square. So it will factor into y and y, 2 and 2, minus and plus. And again, it doesn't matter which one is minus and plus. I really try to reiterate that. 8 and t, and we go in the order. So 8 and 8, t and t, minus plus or plus minus. The next one, oh, I did the next one already. All right, sorry, I didn't realize. I don't know, should play those numbers. But in any case, you can see that the order just changes. So sorry about that. I didn't mean to give you the same one twice. For E, 81 a to the second is 9a, and then 10b. So everything has to be a square, including the exponent. So if one part of this is not even a square, we're going to have a problem. So again, I really just want to make sure you understand that. So we're going to have 9a minus 10b and 9a plus 10b. And you're going to see a lot of this come up, so it'll be nice. The next one is going to be 4mn, and then 1, the square root is just 1. So 4mn plus 1, 4mn minus 1. Okay, I'm going to come back to G last. G is going to be a special case. I'm actually, sorry, no, G is not a special case. So t to the 4th, the square root is t squared, and then 36. So again, remember, I did x to the 4th before as x squared times x squared. So it would be t to the 4th, t squared, and t squared. So we have t squared plus 6 and t squared minus 6. Now, I'm just going to show you right here. This looks like it could be another difference of squares because there's a minus in between. T squared is a perfect square, but the reason it's not is because 6 is not a perfect square. Now, we're going to see this come up where we would get another difference of squares inside, but right now we're not quite there. So I don't want anyone to get too upset, upset about that just yet. We'll get there and it'll be fun. 11x here, and then 5 over 2 here. So 11x plus 5 over 2, and then 11x minus 5 over 2. Okay, and that is the difference of squares factoring. So let me pause to let you guys catch up. If anyone has any questions at this point, I'm happy to answer them. And then we're going to go into our third special case, which is going to be slightly more interesting as it's a case that you probably have never seen before, but I will certainly help you guys in doing this. And we're going to go a little bit slower with this new concept because of the fact that it is a little bit tricky. So I'll give you guys just a moment to catch yourselves. If you need to take a break and get away from the screen, you can. I don't suggest you leave me too long, but I understand that this is not always easy to sit here for 2 hours staring at a screen. So I do it all day, so it's super fun. Okay, so the third type of factoring is a little bit tricky, so I'm going to break it down in the easiest way possible. We are able to factor what we call a sum and a difference of cubes. Now, we cannot factor when we had a plus in between a difference of squares, but we can when we have a plus in between a difference of cubes. And let me, I'm sorry, a sum of cubes. And let me explain what I mean by all of that. Okay, so if you guys see, each of these are perfect cubes. Now, perfect cubes are going to be that they have the same variable. They have, let me start that over. A perfect cube is going to be the same factor multiplied by itself 3 times to give me back that value. So 1 is a perfect cube because 1 times 1 times 1 gives me back 1. 8 is a perfect cube. 8 times 8, 2 times 2 times 2 gives me back 8. I'm just on the wrong page in my notes, so I'm all. 27 is a perfect cube. 3 times 3 times 3. 64 is a perfect cube. 4, 4, 4. 125, 555, 1000, 10, 10, 10. Now, these are the ones that you guys should be most familiar with. Perfect cube exponents are going to be divisible by 3. X to the third is a perfect cube because x times x times x gives me back x to the third. So the cube root of x to the third would just be x. X to the sixth is a perfect cube. X squared, and x squared give me back x to the sixth. We normally don't go higher than that, but x to the ninth is a perfect cube. X cubed, and x cubed give me back x to the ninth. I'm going to draw a line because we tend to not go past here. So this is the general form of how these factor, but I'm going to make it easy for you guys, and it's going to be a little bit confusing. I'm going to be really honest with you in the beginning. So give me a few examples to let me show you, and then hopefully after I do 1, 2, or 3 of these, you will be able to do that without me. So I'm going to do 3 problems for you, and then I'll let you guys try them without me. Okay, so for my first example, I see there's a plus in between. So it's a sum. Now I look at the terms. X to the third is a perfect cube because its cubed root is x. X times x times x. 1 is the perfect cube. Its cubed root is 1. Now, this is going to factor into 2 things always. A binomial, so a 2-term expression, and a trinomial, or a 3-term expression. What I tell my students to do next is to fill in the signs. So please listen carefully. This gets a little confusing. Whatever we start with goes inside of the binomial. So if it's a plus in between, the binomial is plus. If there's a minus, the binomial is minus. We then go opposite the sign here, and the last term is always positive. So I'm going to write same sign as what you started with, then opposite sign, and this is always positive at the end. Okay, and I'm going to do it the other way just to show you guys as well. Whatever we write down here, so whatever the cube root of each term is, goes in the binomial. The product of the terms in the binomial goes in the middle. So x times 1 is just x. The first term of the binomial gets squared. So x squared is just going to be x squared. And the second term of the binomial squared goes on the outside. So 1 squared is 1, and that would be the entire factoring. I know that's a lot, so I'm just going to ask you to write it down. I'm going to actually redo this problem again for you guys to watch. So I know that you are confused. I know you're going, what the heck just happened? And that's totally normal. Just bear with me. Let me explain it again. And then I'm going to just show you guys one more instance, and then I'll take any questions you might have on this first example. Okay, so let's do this first example one more time. So now I'm going to go through it all one more time. Okay, this is a sum, so it can't be a difference of squares. So I check to see if it's cubes. This is a perfect cube. Its cubed root is x. This is a perfect cube. Its cubed root is 1. Now you have to train yourself. This will factor into a binomial and a trinomial. Since I started with a plus, this will be positive. This goes negative or opposite. I just move this. And this goes plus. So plus, minus, plus. If it started with a minus, I'll do that after. The product of these 2 values goes in the middle. This value, oh, sorry, they should have gone in here. So the terms go inside the binomial. Sorry about that. This will get squared and go in the first part. This will get squared and go in the second part. Now, the only difference if this was a minus would be that it's a difference of cubes. This is still x and this is still 1. So this would go minus. This goes opposite. This always ends in plus. The two terms go inside the binomial. Their product goes in the middle. This gets squared and goes here. This gets, sorry, I didn't mean to do that. This gets squared. I can't write now all of a sudden. This gets squared and goes there. Okay. So let me pause. Let me let you guys digest this. Let me take any questions you guys might have. If not, I'm going to model another one for you right away. If you want to just watch another one and you think that might help, that usually does, but I'm open for any questions if you have. Okay. So what I actually am going to do is I am going to make up another example so that I can allow you guys to try all of these without me. So I'm going to go all the way down here. So maybe you want to find some space in your notes, and I'm going to make up my own example right now. Okay, so I'm going to make it 27 a to the third minus 8. Do I have a 27 and an 8 together? I don't. Let's do 20. Let's do 8b. Let's just do 8 to keep it simple. Okay, so I'm going to look at the sign in between. It is a minus. Then I'm going to see if it's squares. They are not perfect squares, but I am going to check if they are cubes. 27 is a perfect cube. Its cube root is 3. A is a perfect cube. Its cube root is a. And 8 is a perfect cube. Its cube root is 2. So I have 3a as my first term and 2 is my second term. I'm now going to go into my signs. Because I started with minus, this goes minus, this goes opposite, this always ends with plus. The binomial gets these first terms, so 3a and 2. Their product goes in the middle, so this is 3a times 2, which is 6a. This value gets squared. Now the whole thing gets squared, so it's not 3a squared, it's 9a squared. And this value gets squared and goes here. 2 squared is 4. And that's it. So I know that's a lot, but let me know if you have any questions. If not, I want you guys, it is now 9 p.m. Wow, it's 9 o'clock already. That's okay. I want you guys to try B, C, D, and E. So that's 4 questions. Let's give you guys about 2 minutes per question. So at about 9:07, 9:08, I'll start going over them, and then maybe we'll do F and G together. Okay, so if you guys want to get that going, that would be wonderful. If anyone gets stuck at any point, let me know. If anyone has any questions at any point, let me know. Okay, so please feel free to raise your hand or unmute at this time. Okay. Oh, let me slide back up so you guys can see the questions. I'm going to erase what's on the screen in a few. So if anyone still needs it, please get it now.
Are we doing B through E?
B through E. And if you finish early, go even into the next question after that. Yep, B through E. Okay, I'm here if anyone gets stuck. Okay, so we'll start in about 7 minutes going over these. Okay, so about 6 minutes. You guys should be working on C and or D by now. All right, I'm gonna erase this at this point in a moment, so if anyone still needs it, please get it now. We're doing really great, guys. And again, remember this is being recorded. I will post it on my site for you guys. And it's going to be up to you to recognize if you have a difference of squares or cubes. Some are difference of cubes. That's just going to take a lot of practice. Okay, so we'll start in about 4 more minutes. Okay. Okay. About another minute or two. Okay, about another minute, last minute or so. Okay. All right, so obviously each one of these is going to be a difference or a sum of cubes, but again, we'll talk about why. So for B, it is a difference. They are not squares, but they are cubes. We start with minus, so minus, minus, then plus. Okay, so we're going to have y and 2 go in the binomial. Their product goes in the middle of the trinomial. Y squared, so this value gets squared and goes here. This value gets squared and goes here. So these should be your factors, y minus 2 and y squared minus 2y plus 4. For our next example, we have 27 is a perfect cube. T is a perfect cube and it's a sum. So we start with plus, so plus, then we go opposite, then we go plus. The product of 3 and t goes in the middle, so 3t. The 3, I always forget to do that binomial first. Sorry, guys. The 3 goes on the outside and gets squared, so 9. The t goes on the end and becomes squared, and it's 9 minus 3t plus t squared. Okay, I'm just letting you guys catch up. For D, again, it's a plus, so it can't be a difference of squares. So we check if they're cubes, and indeed they are. Now this one could be a little tricky, so I'll definitely go a little slow with this one. So we start with plus, so it's minus, then it's plus, then it's plus. 5m and 2n go in the binomial. So here we're going to multiply them. We get 5m times 2n, which is 10mn. The 5m gets squared on the first term and becomes 25m squared. The 2n gets squared and becomes 4n squared on the outside. Not that it's too tricky, but you just really want to make sure that you also square the coefficient. I see your hands, guys, and I'm not ignoring you. Just give me a couple of moments to finish and I'll get your questions. Or you know what, while people are catching up, let me just do them now. I'll get your questions. I saw some hands. Julia?
I do believe indeed there is a sum. It's not a difference.
Letter D?
Yeah.
Oh, I wrote the sign wrong, plus. Sorry. Might have been looking at E. Thank you. So it's plus, then it's minus, and then it's plus. Better? That should be better.
Yes. Thank you.
Thank you. Indira?
It was the same thing.
Oh, sorry about that. Yeah, thank you. I guess I was looking at E, but I was doing D. Anyway, last one, cube root of 1,000 is 10. Cube root of 64 is 4. And cube root of x to the 3 is x. Let me make sure I get my signs right. So now we're good. Minus, I was looking down. That's why I did do plus. And then plus and plus. So Indira, you still need me?
No, sorry.
Oh, that's okay. I saw you, so out of the corner. You're fine.
I
So
took it down.
no, that's cool. Listen, who is ever going to get used to this world? So their product goes in the middle. We got a 40x. The 10 gets squared in the front and becomes 100. The 4x gets squared and becomes 16x squared. Okay, so hopefully you guys didn't have too many issues there, but I'm happy to answer any questions. If not, we're going to go into our last two, with G being a little bit of a special case. And then we're going to go into our last piece of factoring, which is completely. I'm going to leave about 10 to 15 minutes at the end of class to go over the first half of the exam. But I do want to start lesson 6. It's going to really put us in a good place. Even if I could do the first slide or two, it would really be great for us for next Monday. Okay. Maria, go ahead and then I'll get started.
Yeah, so I just wanted to ask, both of those basically needs to be able to be cubed, right?
They both have to be perfect cubes.
Okay.
Yep.
Yeah, that was my question.
Yeah, no. So what you would want to do is you would want to ask yourselves, do I have a difference of squares first?
Mm-hmm.
If I don't have a difference of squares, then it's going to be, do I have possibly a difference of cubes?
Mm-hmm.
And automatically, if you have a plus in between, then that can't be a difference of squares because we can't have a plus and then both be perfect squares. That's it.
Okay.
Mhm.
Yeah, okay, got it, thanks.
You're very welcome. Okay, last question I'm going to do with you, and then G is a nice special one. So 64, so again, here we go. So 64, so we have a minus in between. 64 is a perfect square, but the exponents 3 aren't, and neither is 125. So then we ask ourselves, could it be a difference of cubes? And indeed it is. Binomial, trinomial. Okay, so we're going to go minus, then plus, then plus. Their product goes in the middle. So it kind of just, it's like a pattern that you just have to get used to. These go in the binomial. I always forget to do that first every single time. 4a gets squared in the front, and then 5b gets squared in the back. Okay, so I'll let you guys catch up. And then I'm going to give you a head start on G. So I'm going to give you guys a little bit of a head start on G. G is not any more difficult than anything we've been doing so far this evening. It's just got a little bit of a twist to it that I think you guys will find interesting. Yeah, we're going to be in a really good place for Monday. I'm really happy we did so much tonight, guys. You guys are really kicking butt with this stuff, so that's great. Okay, so let me get you guys going on G. So this is a special case because we have two situations here. And I want you guys to be careful about this situation. So this can be considered two different things. Now, will this come up on your final, this type of question? No. But I threw this at you because I thought it would be a nice thing to kind of trip you guys up with. So what do I mean? Well, this can be a difference of squares. Because there's a minus in between. Y to the 6th is a perfect square. Y cubed times y cubed gives me y to the 6th. And 64 is a perfect square. Its cubed root is 8. I mean, square root is 8, excuse me. So when I factor these, I get y cubed minus 8 and y cubed plus 8. And so this is a really tricky question because these are also difference and sum of cubes built in. So I would have to factor both of these at the same time. This is a difference. So let's start with the y cubed minus 8. So y cubed minus 8 is a difference of cubes because the cube root of y to the 3 is y and the cube root of 8 is 2. And this would be a sum of perfect cubes. So let me kind of separate them from each other. So the binomial, trinomial. Okay. So I'm going to get y minus 2, y squared plus 2y plus 4 when I do all my magic. And then for this one, I'm just going to get the same thing, but it'll be y plus 2, y squared minus 2y plus 4. So the final answer here would be all 4 of these factors. Okay, so let me repeat what just happened while you guys catch up. It could be seen as a difference of two squares. So when we factor, we get y cubed minus 8 and then y cubed plus 8. And those happen to be both difference of cubes and sum of cubes. So we get y minus 2, then the trinomial, y plus 2, then the trinomial. This can also be treated another way, but I want to give you guys some time to catch up before I actually discuss that. And again, you will not see anything like this on an exam, but I just thought it was a nice thing for you guys to sort of see as a challenge, if anything else. This could also have been viewed as a difference of cubes right away. Y to the 6 is a perfect cube, and 64 is a perfect cube. So my binomial, my trinomial, I go minus, plus, plus, y squared minus 4, 4y squared in the middle when I multiply them, Now this would be y squared squared, which is y to the fourth. This would be 4 squared, which is 16. And then those would ultimately factor further, but I'm not going to get into trinomial factoring just yet because I didn't teach that. So my whole point is that sometimes you can have a difference or a sum of cubes built into a problem, which segues us into the last piece, which is factor completely. So before I start that, basically up until G, I'm hoping you guys were okay with. If anyone still needs a little more clarification on G, I'm happy to answer that. But what I'll love to do is answer that sort of after the fact, because this is kind of just a little bit more of a challenge. So to reiterate, we discussed a few problems tonight. We first, when factoring, checked for a GCF. So when you guys factor, that will be the first thing that you check for. After that, you will check for a difference of squares. And then if that doesn't exist, you will check for a difference or a sum of cubes. So in this order is how you guys will factor completely. Let me move this little box so you guys can see. So I'm going to start with letter A to show you what I mean. And then I'm going to give you guys, I'll actually do A and I'll do A and I'll do C for you guys. And then I'm going to have you guys try the rest. But factoring completely means that you're going to check for all of these things, making sure that you cannot factor any further. So let me start with A. So the first thing I check for is a GCF. There is a GCF of 2. Since there's a GCF of 2, I'm going to factor out that GCF. And then I'm going to see if I can factor any more. Well, the second thing I check for is there a difference of squares? In this case, there is. X squared minus 4 happens to be a difference of squares. So that will factor into x plus 2 and x minus 2. And I can see that those 3 factors cannot be factored any further. So that means I factored completely. So it's sort of a combination of all the different types of factoring we've seen so far. I'll do one more for you guys, and then I'll leave the others for you to try. And then, of course, I can clarify anything you guys need. So let me try C with you. So the first thing I check for is a GCF. There is a GCF of 3xy in both of my terms. I'll let you guys sort of make sure you're okay with that. When I factor out the 3xy, and now you notice I'm not doing that dividing anymore, I'm left with y minus 3 inside of my, y minus 9 inside of my parentheses. And then I'm going to look to make sure that I cannot factor anymore, and 3xy and y minus 9 cannot be factored anymore. So I factored completely. Okay, so I'll leave it to you guys to now try the other examples. I'll take any questions you guys might have. Okay, I'm going to introduce some trinomial factoring this evening. And then I'm going to go over the first 12 or 13 problems of the exam. While you guys are working, I'm just going to say that if you want to know what your exam grade is, you just double the points because it was out of 50. If you didn't do as well on the first, there will be 3 more exams in this class. So please understand you have plenty of opportunity to boost your grade. And I'm also not evil. I will work with you in terms of getting yourselves better. If you're concerned personally, you can email me or stay on at the end. But remember, there may be other people, so email might be better. Your next exam will either be the 26th or the 28th. So that would be 3 weeks from now. I'll let you know specifically when. The exam for some of you guys, I know there was a little bit of a glitch. So again, I'm going to reiterate that you have to upload your work. I don't think I had many issues with people on that. What I am able to do is then go see what your answers were. Many of you were very neat with your work, and that was great. I also, when I go over the test is scrambled for everyone. So I'm just going to go over my version and then you can match it to yours. You guys should be able to see your exams now. If you can't, let me know and I'll check the settings, but I'm pretty sure I released them. Okay, so we'll do that at the end. I'm going to stop at 9:45 to do that for you guys. Okay, I know our class ends at 10:10. Indira?
So the grade is on Blackboard or no?
So the grade is on Blackboard. So let's say you see, just going to make up a number here. If you see a 48, that's a 96.
I don't see anything on mine.
Under test one.
I'm where it says test 1.
Under Grade Center?
Oh, in grade center.
Under Grade Center. All the grades.
Oh, okay.
You should be able to see the grades too, the exam too, but if not, I'll check on the settings. But I'm just going to go over that. And then if any of you aren't seeing that, I'll check on my settings after.
Yeah, mine doesn't show.
All right, I'll look after. If I can't do it before I start going over it, what I'll do is I'll tell you guys to write it down and then I'll check either after class or first thing in the morning, okay? I just want to make sure we do our material, but I'll check. You should be able to see them, the release, but I'll check on it again, okay?
Okay.
Yeah, thank you. All right, so let's get started, guys. So there is no GCF for letter B. This is a difference of squares, however. X squared and y are the perfect squares. So we get x squared minus y and x squared plus y as our factors. And that cannot be factored any further. For letter D, there is a GCF of 4m cubed. When we factor that out, we're left with 8n cubed, plus 1. There is no difference of squares, but there is a sum of cubes. 8n to the third is a perfect cube. Its cubed root is 2n. 1 is a perfect cube. Its cubed root is 1. So I'm going to continue with that over there. So this will factor into a binomial and a trinomial. The number one thing that people forget is the original GCF. It goes plus, then minus, then plus. So 2n plus 1 in the binomial. Their product goes in the middle of the trinomial. This would be 2n squared, which is 4n squared. And this would be 1 squared, which is 1. And that would be the complete factoring. So there it is, sneaky, sneaky, where we may have a GCF, and then we either see a sum or a difference of cubes. So we have to be careful if we don't have a difference of squares to always check for that as well. Okay, I'll give you guys a couple of minutes there. Okay, for letter E, we have a GCF first of 4. When we factor that out, we're left with x squared minus 16. There is now a difference of squares. So the factors will be x squared minus 4 and x squared plus 4. I'm sorry, x minus 4 and x plus 4. Sorry about that. And we cannot factor any further. So we are done there. For letter F, we have a GCF of 12. We are left with u cubed minus 1. There is no difference of squares, but there is a difference of cubes. The cube root of u to the 3 is u. The cube root of 1 is 1. So we will bring down our original GCF and then our binomial trinomial. U times 1 will go in the middle of the trinomial. U squared will go in the front of the trinomial. And 1 squared will go in the back of the trinomial. trying to sign onto Blackboard to see what's up with the exams, but it's not allowing me to get on for some reason, so. And then finally for G, we do not have a GCF, but we do have a difference of perfect squares. The square root of 9x is 3x, 9x squared, and then 9y squared from 81y to the fourth. And then, of course, the same thing with a plus in between. So now you guys have officially learned how to use GCF factoring. You've learned how to use difference of squares factoring. You've learned how to use sum and difference of cubes factoring. And of course, you learned how to combine all three into factoring completely. Now, this is the first part of your homework, which is due next. I'll get to you, Victoria, which is due next Wednesday, but you guys can start it. Go ahead, Victoria.
I have a question. So
Sure.
E, right? Could E be the difference of squares?
Uh,
2x minus 8?
Yeah, sure. Okay, but remember, the problem with that is if you don't factor out a GCF first, you would get 2x minus 8 and 2x plus 8.
Yes.
But now there's a GCF of 2 here and a GCF of 2 here. So you would have to then factor out that GCF from each of those. You see what I mean?
Okay. Mhm.
So that's why I'm going to reiterate that we always check for a GCF first, because if we can catch the GCF first, then we don't have to, we're not going to miss it at the end, because potentially you could miss it if you did it the way that you had said.
Okay.
You follow me?
Yeah.
Okay. You're welcome. Anyone else? I'm good. By the way, I will post these notes, but anyone else before I open up lesson 6? Okay, so I'm going to open up lesson 6. I'm watching the time, but I do have about 15 minutes. So I would like to start lesson 6. Even if I do 1 to 1.5 slides, it will put us in a good position. So trinomial factoring will be our next piece. And more importantly, for the majority of our questions, we will be factoring what we call quadratic trinomials. Okay, so I'll let you guys get yourself settled. And we're going to look at the first type of trinomial. And then we're going to talk about some factoring by grouping, hopefully for a few minutes. And then we will resume with this on Monday. P.S. What you're about to see was also taught in M200 if you took M200. So you should recognize a lot of what I do with you guys here. Okay, so if we see something that looks like ax squared plus bx plus c, they will factor into 2 binomials. Now, if the value in front of x squared or the the variable squared is a 1, the factoring is very easy. We are going to write down 2 binomials for each one of these. Okay, I'm just getting them set up so you can see that it will be the same throughout. Okay, and we are then going to factor this very easily. So we're going to start with the first term, which is x squared. And we know the only way to multiply back to x squared would be x times x. So for b, it would be k times k. For c, it would be y times y. For d, it would be x times x. And I'm going to stop with those 4. You guys are going to try the other 4. Now, we are going to look for 2 numbers that multiply to the last term, but add to the middle term. Okay, so the last term is c, and the middle term's coefficient is b. So factors of 8 that add to 6, well, 1 and 8 do not add to 6, but positive 2 and positive 4 add to 6. So the factors are x plus 2 and x plus 4. And if you wanted to check this, you could use FOIL. X times x is x squared plus 4x plus 2x plus 8, and we get back the middle term of 6x. Okay, so I'm going to do the first with you, and then you guys will be able to do the other 4 without me. Okay, so again, we decided k times k. So we're looking for 2 numbers that multiply to 49, but add to 14. 1 and 49 do not. The only other factors of 49 are 7 and 7, and they do. And since the last term is positive and the middle is positive, positive 7 and positive 7. For the next situation, I'm just going to ask you to hold your questions till I open up for them. We have y times y is y squared. So here the last term is 20. So I need factors of 20 that add to negative 9. 1 and 20 will never get me to 9. 2 and 10 will never get me to 9. 4 and 5 can get me to 9. Now I have to multiply to a positive 20, but add to a negative 9. 2 negatives multiply to a positive 20, but add to a negative 9. And again, in this case, the order does not matter. Finally, the last one, x and x is x squared. So I need 2 numbers that multiply to positive 12, but add to negative 7. 1 and 12 will never get me to 7. 2 and 6 will never get me to 7. 3 and 4 will, so I need to multiply to a positive 12, but add to a negative 7. 2 negatives multiply to positive 12, but add to negative 7, and there are your factors. Okay, so I'll open for questions at this point. I'm going to give you guys a few minutes to try E, F, G, and H without me. Maria, you can now ask your question.
So basically you're saying that we need to multiply the last part of the equation, like, sorry, not multiply, divide,
Okay,
and then see if that goes into the middle part.
Okay, we're not dividing. We're looking for a pair of factors that are multiplied to the last term. Be careful when you say equation. I know what you mean, but it's expression.
Mhm.
Add to the middle term. So you're
Okay.
looking for pairs of numbers that multiply to the last term, but add to the middle term.
Okay, and if it's negative in the first term, in the second term, the sign in the parentheses is always going to be negative.
So if the last term is positive, you can only get to a positive with 2 positives or 2 negatives.
Uh-huh.
If the last term is negative, then one of them has to be positive, but then you have to decide. So you're going to see that happen in question G.
Okay, and it doesn't matter which side is going to be negative, or it does matter.
Yeah, it does if there's one positive and one negative. It does.
Okay.
Okay. But if you go through every example that I went through so far, multiplication to positive 8 and add to positive 6, positive 2, positive 4. Multiply to 49, add to 14, positive 7, positive 7. Multiply to 20, but add to negative 9, negative 4, negative 5, because 2 negatives multiply to positive 20, but add to negative 9. 12, 2 negatives multiply to positive 12, but add to negative 7.
Okay.
So try not to make it a memorization thing here.
Okay.
Julia?
Yes. G, do we miss an coefficient where is y?
What, oh, you missing, sorry?
Y to the 2 plus y minus 30?
Yeah.
Oh, okay.
What's the problem with it? I'm sorry, maybe I'm not understanding.
I don't know what kind of 2 numbers will be multiplying and we will have minus 30.
There are, I promise. So let me get to you.
Okay.
Okay?
Mhm.
I promise there is.
Okay, thank you.
You're welcome. I got you right now. So let's start with E. So I'm looking for So it's obviously y and y. By the way, we're going to change on Monday when the value in front of the squared is more than 1, but not tonight. So here we go. We need two numbers that multiply to 70, but add to negative 17. 1 and 70 will not. Now, you should really be like a little more on a mental thing with this. If you kind of just think about the numbers, 10 and 7 multiply to 70, but if they're both negative, they will add to negative 17. So you don't want to go through every pair of factors at times, because that could also be very time consuming. To multiply to 144, but add to 24, 12 and 12. So again, that just comes from a little bit of mental. Let me come back to G last. So for H, you're going to have multiplying to 121, but adding to negative 22, negative 11, and negative 11. Now for G, I want to multiply to negative 30, but add to positive 1. Factors of 30 are 1 and 30. That will never get me to 1. 2 and 15 will never get me to 1. 3 and 10 will never get me to 1. 5 and 6 can get me to 1. How? Well, if 6 is positive and 5 is negative, 6 plus negative 5 gives me positive 1. And it doesn't matter where I put the plus 6 or the minus 5, but it does matter that the 6 is positive and the 5 is negative. So I'll just state that. Okay, Julia, did that help then, Indira?
Yes, I was just wondering, because I put in E, I put it the other way around.
Fine.
It's okay, it doesn't make it wrong, just because 7 is,
So what did you write? Y minus 7, Y minus 10?
yeah, because you put in all of these that you did in A, B, C, D, you put the smallest number in the front. I don't know if it was like,
That was coincidental, but I like that you're paying attention.
yeah, so I'm like,
To be honest with you, it does not matter. I wrote my famous
oh, okay.
numbers on the top. If I say to you, what is 2 times 3, you tell me 6, right? If I say, what is 3 times 2, you tell me 6. So the point, very nice observation. I did not do that intentionally. I promise you that. But no, thank you for paying attention to me. What I will say to you though, is that was coincidental, okay? No, it does not matter, but it does matter signs. Okay, so let's do this. I'm not going to start the factoring by grouping. I'm going to just open up a web page for a minute. I'm going to pull like a couple more, maybe 2 or 3 more of these types of questions. And then we'll go over the exam, and I'll start the factoring by grouping on Monday. I think that might not be a bad idea for us tonight. Okay, so let me give you guys like 2 or 3 more problems to try. So why don't you guys try these? So let's make it I, J. Let's do 4 more for good luck, okay? So let's do x squared plus 3x minus 28. Let's do x squared minus 14. I'm just going to leave them all as x. Let's do x squared minus x minus 6. And let's do x squared plus 15x plus I think that one factors. Okay, so you guys can try those 4. I think that one works. Indira, are you good now?
I'm fine, I'm sorry, I didn't
Okay,
lower
yeah,
my
no,
hand.
don't apologize. I closed the screen, so I didn't see your hands. But you guys can now try this stuff for sure, before Monday. So really, get yourselves up to speed on all this. So we'll do these, and then I'm gonna go over a little bit of I'll do half tonight and half on Monday, just so you guys are good. By the way, I'm gonna ask you to have lesson 6 for Monday. I'll also post 7 before the weekend. So if you guys can have 7 ready, that would also be great, just because then we can, keep ourselves moving ahead. So we'll start in about 2 more minutes. I'll post the notes for 5 tomorrow morning and the recording. Okay, so let's do this. And hopefully you guys got like a little more mental with this in terms of being able to do it in your head. I don't mean mental like crazy. Okay, so here we go. Factors of negative 28 that add to positive 3. Well, when you think about 28, 1 and 28 don't work. You could almost do it like that. 2 and 14 don't work. 3 doesn't go into 28, excuse me. 4 and 7 do though. Now, you have to decide which one is negative and which one is positive. Well, if I want to add to a positive 3, it has to make sense that 7 is positive and 4 is negative, because if 4 is positive and 7 is negative, it would become negative 3. So it's x minus 4 and x plus 7. J, so I'm looking for factors of 48 that add to negative 14. 1 and 48 don't work. 2 and 24 don't work. The next number is 3 and 16, which don't work. Then I have 4 and 12, which don't work. So we're getting there. We're not quite there yet. 5 is not divisible. 6 and 8 do multiply to 48 and also add to 14. If they're both negative, they would add to negative 14. So x minus 6 and x minus 8. For K, we're looking for factors of negative 6 that add to negative 1. 1 and 6 will never get me to 1, but 2 and 3 will. If 2 is positive and 3 is negative, they will become negative 1. So x plus 2, x minus 3. And the last one, factors of 56 that add to 15. So 1 and 56 will never get me to 15. 2 and 28 would never get me to 15. 3 is not divisible into 56. 4 and 14 would never get me to 15. 5, what I say, 6 is not divisible into 56. 7 and 8 are, however. And 7 and 8, both positive, will add to positive 15. Sorry about that. And multiply to positive 56. So it's almost like a little bit of a puzzle in the sense that you guys have to just work out the idea of what will multiply to the last term, but would add to the middle term. Okay, so any questions here before I spend a few minutes going over the first half of your exam?
Yes, I'm a little bit confused. Maybe I'm missing or I'm confusing the rule for what needs to be added to the number in the middle. Because I'm still trying to figure out how did you get negative 4 and 7? I understand the 7, but
Okay, why?
go ahead.
Okay, so when you think about factors, and then what I'll do is let me explain this one, and then if you're still stuck, you could stay on after, and I could do a little bit more of this. So when you're looking at the factors of the last number, you're asking yourself, what pair of factor will add to my middle term, but still multiply that number? So when I think about 28, let me work 28 out on the side here. 1 and 28 can never get me to 3 regardless. Right? They can never add up to 3 regardless. 2 and 14 can never add to 3. 3 does not go into 28, so that's out of the picture. 4 and 7 can can multiply to 28, but could also get me to 3 somehow. Well, how would they get me to a positive 3? Well, if I make the 7 a negative and the 4 a positive, then that's a negative 3. So what I'm going to do is I'm going to make the 7 a positive and the 4 a negative, and now that would be a positive 3. So negative 4 times 7 is negative 28. -4 plus 7 is +3. Does that make sense? Arian?
Yes, I'm sorry.
No, go
Okay,
if you
now
want.
I understand, yeah.
Okay, it takes a little bit of time. Anyone else that has any pertaining to the material today, stay on and I can, reinforce that a little bit more. Let me do these. I'm gonna do questions 1 through 12 or 13 from your exam. Now remember, your version of your exam, it's the same questions, but it may be jumbled. So I will, of course, write down the original question, but I'm not going to write down the multiple choice answers, guys. So I'll just give you what the answer choice would have been and what the question was asking. So let me go over the first 13, and I'll do the other 12 on Monday. And then I'll spend a few minutes reiterating whatever you guys need, okay? So if you still need me after I do this, stay on. And just remember, guys, that your homework is not due till next Wednesday, but started anyway. So the first question asked for the additive inverse, okay? And then it asked for the multiplicative inverse in that order. So the additive inverse is found by just negating the sign. So the additive inverse would have been 3 1/9. The multiplicative inverse, we need to find the reciprocal. So we first change this to an improper fraction. 9 times 3 is 27. Plus 1 is 28/9. I'm sorry, 9. Sorry, what did I do here? This is going to be, oh yeah, here we go. 9 times 3 is 27, plus 1 is 28/9. So that's the original number in improper form. And the multiplicative inverse means to just take the reciprocal. So this is the additive inverse. This is the multiplicative inverse. The answer was choice D. After I go over all of this, I will post these notes for you guys as well, so you can review it with what you guys did. Number 2, I'm just going to work. I'm not going to rush, but I want to make sure I have enough time. So I'm just going to write them a little quicker. Okay. So this was an order of operations question. We always work inside of the brackets first. So 8 minus 3 plus 2 is 8 minus 5. I'm just going to rewrite everything I didn't use. This is going to be 3. And now I can drop the brackets because I have a single number inside. Now I go from left to right. So I'm going to do the division, multiply first. 8 times 9 is 72. And then I'm going to do the division, which is going to be 8. And then 72 plus 8 is 80, choice A. Number 3, to be honest, these PEMDAS questions are an M1 topic. Not that I'm trying to make anyone feel bad, but we got to know how to do these. So we start with the parentheses first on top. That would be 3. The exponent on the bottom would come next. That would be 9. The numerator, we're going to do 40 times 3, which is 120 minus 12 over 6. 120 minus 12 is going to be 108. 108 divided by 6 is going to be 18. That is choice A. Number 4, which number is irrational? Choice A was 3.14. This is not irrational. 3.14 is not the same as pi. 3.14 is a terminating decimal. Many people chose that, and that answer is incorrect. Radical 2, so this was the answer. This is a non-perfect square. All non-perfect squares are irrational. Choice C was radical 4. This is a perfect square, so it is rational. And choice D is a repeating decimal, so it is rational. Guys, 3.14 is not irrational. Pi is irrational. Number 5, and again, remember, this is my version of the test, so it's definitely different than yours in terms of the order. The questions and the answers are the same. Okay, so this is going to be that we are going to divide 6 divided by 2, which is 3. Then we're going to subtract our exponent. 2, oh, actually, they cancel with each other because anything divided by itself is going to just be 0 or go away. Then I have b to the 3, 7 minus 3, which is 3b to the 4th power. This is choice B. Number 6 is 3x squared y squared, and then x to the 5 times negative 3. So we always like to get rid of negative exponents first. We're going to take this x to the 5 and put it in the bottom, and then it would become positive. And I'll just rewrite what is left over. X to the 5 raised to the 3 is going to be x to the 15. You can rewrite this as a single fraction to make this a bit easier. Okay. So when we subtract our exponents, we get negative 13. We cannot have a negative exponent, so we will leave the y and the squared and the 3 in the top, and the x to the 13 flips into the bottom and becomes positive. The next question that I have, they told you that x is negative 4 and y is negative 5. So negative 4 plus 9 times negative 5 is negative 49. This is choice B. Okay, I'll give you guys a little bit of time to catch up. I'm just going to do through number 13 for this evening. Okay, so there was an issue with this question. There was a typo there was no answer. I'm going to give you the right answer, but I gave you credit if you got it wrong. If you got it right, you didn't lose any points. So I'm going to give you, and I forgot who told me, but thank you if it was you. So we're going to square everything first in the top, 16. This is going to be x to the 6th, y to the 14. 16 divided by 12 is 3 over 2 because 16 and 12 have 4 in common. All the answers had 2 over 3, so that's where it went wrong, and I apologize. Then we have x to the 6 minus 8, which is x to the negative 2, and y to the 14 minus 10, which is x to the 4. I'm sorry, y to the 4. The x to the 2 cannot stay negative, so we will flip it into the denominator and it becomes positive. So this is what the answer should have been. But again, I gave you credit if you were marked wrong because that's not fair. This one, a lot of you guys, Julia, hold your question for, well, go ahead, Julia.
How we got 3 out of 16? I do believe it's 4 to the 3rd.
4. It's, wait, 4, it's 16 and 12, so it's 4 on top. Yeah, not 3, right?
Yeah, and 3 on the bottom.
And 3 on the bottom. I didn't divide correctly. Thank you. 4 and 3. But either way, you got it right. Thank you. That's me rushing. Do I hate rushing? Okay, 4, 3. So it's 4 y to the 4 and 3x to the 2. Thank you. That should have been the right answer. But in any case, like I said, I gave the credit. For this one, you have to raise everything to the 4th power. So it's x to the 4th, y to the 4th over 2 to the 4th, which is 16. Many of you forgot to take 2 and raise it to the 4th. Not many, a couple of you. Number 10 is a subtraction problem. I don't think anyone really got this one wrong, but I'll do it anyway. Okay, so. Okay, so we're going to distribute the negative into each term here. Whoops, that arrow should have gone that way, but it's all right. So this would be 9n to the 5th, blah, blah, blah. So this becomes negative 5n to the 5th minus 7n to the 3rd minus 12. 9n to the 5th minus 5n to the 5th is 4n to the 5th. Negative 7n to the 3rd and another negative 7n to the 3rd is negative 14n to the 3rd. And negative 16 minus 12 is negative 28. That is choice C. This one made me so upset because so many of you when I say so many of you, I mean a few of you made the same error. So guys, a lot of you did this. You just squared this, and then you did this. and that's wrong. Big no-no. This will always come up on the final. A binomial squared is the binomial times itself. So on my exams in the future, so then we use FOIL or we distribute. In my exams in the future, I do give repeat questions. You know, I'll put topics from earlier units. So please make sure you review all of this. So 36z to the second plus 132z plus 121. This is choice, sorry, B. Okay, I'll do 12 and 13. And then I'll do the other half on Monday, and then I'll post it all. So this was 6x minus 1, x squared minus 4x plus 1. So we distribute each term of the binomial into the trinomial. This is minus x squared. And I also line up my like terms. Okay, another question that often comes up on the final. That's choice B. And then I'll save the rest for, like I said, Monday. But this would just be simple distribution, 10x squared minus 50x, and that's C. I'll check on why the results aren't showing. It might just be my own settings, but I certainly will check on that. Probably not tonight, I'm going to be honest with you guys, but certainly in the morning. So let me just see this because I know it's just about 10 o'clock. If you are good, I would ask you to please bring back lesson 6 and I'll post lesson 7 either tomorrow or Friday. Homework is due next Wednesday, but I'll encourage you to start it. So when we start Monday, I'm going to go over the rest of the test first. Then I'm going to finish lesson 6 and hopefully start lesson 7. Okay. So if you don't need me, I know a couple of you guys did, but if you don't need me, have a great rest of your